Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to have the input as well as concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we are ready to go ahead. Tell me whether the quality of video as well as audio, is it perfect or not? Is it perfect or not? If the quality of video as well as audio is perfect, just write perfect over the live chat and then we are ready to move ahead. Anyways, if you guys would be able to recall in last video, precisely in yesterday's class, we were taking the numericals based on the concept of definite integral, where I was exploiting the result which have come out while taking the Laplace transformation of the different time domain signal. Yes, no? Good evening. Good evening. Pranali, good evening. Manju, good evening. Krutika, good evening. Sir, please let us know if this course covers the entire engineering mathematics. Krutika, one thing is quite sure, all of the important topic I am going to cover here. All of the important topic. I am not saying all of the topic would go into the great detail, but the topic which are very important in terms of GATE and the questions which do come repeatedly in GATE, definitely I am going to cover those topics. So it has been happening. Anyways, focus over the question which we are going to take in today's video. So I have planned to take the 7 number of different questions and all of them has been based on the concept of Laplace integration. Good evening, Nishant. So the first question has been the integral of e to the power of minus x dx from 0 to infinity. Once we are done with this, the second question is again a problem which is relatable to the Laplace integration, where the integration starts from 0, goes till infinity, e to the power of minus x square dx. In the same sequence, we will take the third, fourth, fifth as well as sixth. At the last, we would also be dealing with the seventh question. So what we are going to do over here, part by part, I am bringing each and individual questions over the working board and there we would try to smash that problem out. So let me take this problem towards working board. So here comes the first question of the day. The problem states the integral is given by, where the integration has to be performed over e to the power of minus x dx, where the limit starts from 0, goes till infinity. Tell me what would be the answer for this given problem. And this sort of problem has already been taken in the yesterday's class when we were taking few number of practice questions based on the concept of Laplace integration. In yesterday's class, I gave a little bit idea how the conclusion or how the integration could have been performed with the important Laplace transformation. And from there, we were also taking few number of practice questions. So we have already taken few number of practice questions in yesterday's class. In the same sequence, now we are going to take the 7 number of problem. All of them have been based on the concept of Laplace integration. So I would expect the student who have attended my last class must be able to give the answer not more than 30 seconds. Question 1, the answer have come from Pranali. The Pranali says the answer would be 0.5. Anyone else apart from Pranali? So according to the Pranali, the answer would come as 0.5. See, what would be the concept over here? The x can be replaced with t. So obviously, as far as the integration of e to the power of minus x dx from 0 to infinity is being concerned, at any moment of time could have been taken as integration from 0 to infinity. Rather taking the independent variable as x, I can take this as t. And once we'll connect with its Laplace transformation, may know what used to be the standard structure of the Laplace transformation when we try to get the Laplace transformation of any time domain signal. What it used to be e to the power of minus st. Instead the e to the power of minus st, we had the e to the power of minus t, that means the worth of s has been 1, into xt dt, that means instead the xt we had t itself. So end of the day, as far as the integration of this definite form of the integration is being concerned, you had to take the Laplace of x of t, which has been t, and end of the day it would be a pure function of s, and there the s has to be fed as a 1, which we have already seen in the last class. As far as the Laplace of the t is being concerned, it has been n factorial. The power of t has been n. Here it becomes 1 factorial divided by of s has been raised to the power of n plus 1, that has been 2 over here. And here we would be feeding x is equals to 1. So what's the worth we have been getting? Pranali, it's not 0.5. The answer which we are supposed to get after solving this problem has been precisely 1. So the student who have been new in this video, what I have been doing in the last class, I just made a relationship. As far as the Laplace transformation of any time domain signal is being concerned, basically you take its integration, where the integration has been taken over dt, lower limit had been 0, upper limit had been infinity, and the function had been e to the power of minus st and x of t. And most of the student who belongs from the electrical, electronics and electronics instrumentation, they know the Laplace transformation of quite a few values of x of t. So just exploiting the Laplace transformation of those standard time domain signal, I can get the important integrations also. Sir, I sent 3 questions. Please give solution hint, sir. Manju will see that. I have not seen so far, but still I will try to cover those questions also if it is being sent to our Telegram group. Anyways, let me go into the second question. So probably this question can be smashed over the PDF itself. Tell me what would be the best most answer for the question number 2. What would be the best most answer for the question number 2? What would be the solving methodology? Again focus over the value of s, again focus over the x of t. The x of t had been t square, and this was the place of e to the power of minus st. X is very same as t, so the worth of s has been 1. So end of the day, the integration would land up to the Laplace of t square, and obviously once you take the Laplace of t square, the function which you would be getting in your hand is going to be the function of s, and there s has to be replaced with 1. So the result what we are supposed to get over here, Laplace of t to the power of n is being defined as n factorial, here it becomes 2 factorial, divided by of s to the power of n plus of 1, and here it becomes 2 plus of 1. Anyways, end of the day, we had to feed s is equals to of 1 only. So the answer is precisely going to be 2 factorial, which had the worth is equals to 2 into 1. Obviously, it would be 2 itself, and 1 has been raised to the power of 3, would be leading 1 itself. So the end of the day, result which we are supposed to get after doing all of this calculation had been 2. Similarly, in the same sequence, we took the Laplace of t, and end of the day, the s was fed as 1. Laplace of t is very same as 1 upon s square, and the s was fed as 1, result was 1. So in the first question, we got the answer as 1. In second question, we got the answer as 2. Obviously. So the Nishant have given the correct answer, Pranali, Manju, they all have given the correct answer. So the student who have been following me since very beginning, definitely they are in right track, and they are able to crack most of the problem which has been taught in the sequential manner. May I know what would be the worth of sin t divided by t? What would be the worth of sin t divided by t? Obviously, the integration has been taken over dt. This calculation is already been made in yesterday's class, so most of the student must be able to remember it. Tell me what would be the worth for this given problem. How much worth we have got it? If you want, we can calculate this once again. See, sin t divided by t together has been taken as x of t. E to the power of minus st has been absent over here. What we can do? We can take this as a e to the power of minus 0t. That means end of the day, we had to get the Laplace transformation of sin t divided by of t. The result would be a function of s, and there the s would be fed as 0. Yes, no? Yes. So all of us have got the correct answer, and that had been pi by 2. And keep in mind, for the electrical, electronics and instrumentation, this question has been repeatedly been asked. Means, what should I say? Even they are not changing the variables also, the same problem they have been keep repeating in GATE examination. So you can say the result of sin t divided by of t from 0 to infinity must be by hearted to all of us. In the same sequence, let me move forward with the fourth question. So let me slide this PDF a bit upside, and now let me focus over the e to the power of minus t sin t divided by t. May I know what would be the fundamental which you would be using while taking its definite integral? While taking its definite integral? Tell me. Again, the same fundamental has to be followed, which we have been following so far. First, focus over the x of t. I would take this complete function as x of t. Or no, e to the power of minus t was present over there. So what I would be doing, I would be presuming sine t divided by of t as x of t, and obviously e to the power of minus t can be compared with the e to the power of minus st. Can be compared with the e to the power of minus st. From there at least I got to know, in place of st, there had been the presence of t itself, that means the worth of s has been 1. The worth of the s has been 1. So end of the day, if you really want to find the definite integral value of this definite integral, you had to perform the Laplace transformation over the time domain signal sin t over t, and end of the day, the function which you get after doing its Laplace obviously would be a function of s only. The s would be fed s plus of 1. S would be fed s plus of 1. Tell me how much exact answer we have been getting out of this calculation. So what is happening over here? First, focus over the Laplace transformation of sine of t, which used to be equals to of a, which has been 1 over here, divided by of s square plus of a square. A had been again 1, so it has been 1 divided by of s square plus of 1. So this has been the Laplace transformation of sine of t. And as we know, if there used to be the division of t in time domain, there used to be the effect over the Laplace domain, and the effect is in terms of integration from s to infinity over ds. That is also fine, sir. No issue as such. And once we'll focus over this improper form of the definite integral, 1 upon s square plus of 1. If you take its antiderivative with respect to the s, definitely the result would be precisely equals to tan inverse of s, where its lower limit starts from s and its upper limit goes till infinity. Agreed? Now, the tan inverse infinity has been brought in, has been an upper limit. Tan inverse infinity would be equals to of pi by 2, and here goes tan inverse of instead the s, again the s has to be fed in. The worth of s which has to be put in had been 1. So end of the day, result what we have been getting while doing its complete calculation, it has been 1, no? Just a minute. It has been 1. Has been pi by 2 minus of pi by 4. That has been pi by 4. So I don't find till this point any of the student would have any sort of doubt. So may I know what would be the best most answer? The best most answer has been pi by 4. Here the best most answer was pi by 2. And definitely the first and second questions is already been smashed earlier. Agreed, no? Till this point I don't find any of the student would have any sort of doubt. In the same sequence, let me move forward. And the fifth question is a bit calculative in nature, but still you would be able to correlate this problem from the Laplace form of the integration. So let me bring this problem towards working board, and we would try to knock this problem off there. So here comes the fifth question of the day. Here comes the fifth question of the day, and this problem has come in gate electronics. Exactly I am not able to recall, but probably it is not later than 2018. So somewhere in around year of 2018, this problem has been asked for the electronics student. Tell me what would be its answer. Anyways, before going into the detailed analysis of this problem, I would like to reframe few of the questions for you guys. Let's take, we have taken the integration from 0 to infinity. Instead the sin t divided by of t, let's take, we had the situation of sin 2t divided by of 2t dt. May I know what would be its worth? And how will you calculate this problem? Similarly, in the same sequence, if we rephrase this problem once again, let's take, it has been sin of 3t divided by of t dt. What would be the worth of this problem? In the same sequence, if we take, let's take, you can do like sin of 3t divided by of 2t dt. Anyways, before jumping straight away into the question number 5, I would seek the answer for the first, second as well as third question. And the student who are giving the answer over the live chat, no, they should also refer the question number also. Because I have seen the student randomly start giving the answer. Exactly, I do not able to understand. You have been referring the answer for the question number 1, 2 or 3. That becomes a very misuse. Agreed what I am saying? So if you wanted to give the answer for either of the question, no, first write question number 1 and then write its answer. Then write its answer. Tell me what should be the answer for these 3 questions. These 3 questions. I know many of these students would start solving this problem using the scratch method of the Laplace integration, and once you do so, unnecessarily you are wasting your time. Should I be repeating the same sentence which I have communicated just now? What I am saying, many of the students would say, sir, almost it has been in a form of sin t divided by t. That means this problem could have been knocked up with the help of Laplace integration, and we had to start this problem from the very scratch. Once you will start this problem from very scratch, definitely enormous amount of time is going to be wasted, which is not at all important. And as you have been preparing for GATE, now you should also develop few number of short tricks, few number of process through which without doing any mistake you are able to get its answer optimally with the highest accuracy. With the highest accuracy. Tell me. The first answer have come from Ajay Gupta. Ajay Gupta says the answer would be pi by 2. Ajay, you did the mistake. I know that, I know. That is why I have designed this problem, because the students who have been following me know, they are smart enough. I am not saying you are not smart enough or you won't do mistake over the calculation, but still, once you will see this problem in once through, no, probably most of the students are going to give the wrong answer. Most of the students are going to give the wrong answer. Like Ajay has given the wrong answer. According to the Ajay, he was saying here also we are going to have the answer as pi by 2 as we had earlier. So may I know which process has to be followed? See what we can do. If 2t is being taken as x, so obviously this complete problem would change into the form of standard Laplace integration, and whose result is already known to me, which has been integration from 0 to infinity sin x divided by of x dx is equals to of pi by 2. Yes, so what I am going to do over here, try to understand. I would have the method of substitution. I would take x is equals to of 2t. But once we take x is equals to of 2t, keep in mind the dt should also be replaced in form of dx. So we would take differential from both of the side. So we would be left out with the dx is equals to of 2 times of dt. So let me place all of the substitutions, including variables, including its differential form. See, this was the lower limit of t, as well as this was the upper limit of t. But once what we do, see, try to understand. Once the t has been fed as x by 2, what would happen? T has been fed as x by 2, or x has been fed as 2 into t. What would happen? Once you will feed t is equals to 0, is still the lower limit in form of x would be 0, and similarly once you feed all the way t is equals to infinity, even the upper limit of x would also be infinity only. Agreed? Till this point everything is fine, sir. Sin 2t, the 2t is already been replaced with x, so here is going to be sin of x divided by of x. But one of the major mistake the people may do, and what it is, the dt has to be placed as dx divided by f2. 1 upon 2 had been a constant value all the way, it can be brought out. And from here we are going to get the answer as 1 upon 2 into the sin x divided by of x dx. The integration from x is equals to 0 to infinity is already been calculated as pi by 2. So the worth is supposed to be pi by 4. See, Nishant has done the mistake, Ajay had done the mistake, and Pranali, you are the correct at least in this problem. Definitely. Good job, Pranali. So the answer is going to be pi by 4. So that's what I am saying. I have redesigned this problem such that many of the students who have been following my previous videos know, they would use the short trick, and somewhere here while doing the substitution they would make the mistake. And probably out of 4 number of students, almost 75% of students had made the mistake. Agreed, no? So this thing must be clear to all of us. In the same sequence, let me move forward with the second question. Tell me what would be the best most answer for the second question. Yes, the answer is gonna be pi by 4. See, again the same fundamental would be applied over here. May I know what? What I would do, I would keep 3 towards denominator side just to make this form semantic. Upside also we have 3t and downside also we have 3t. But once you are multiplying 3 towards denominator side, by default towards numerator side 3 has to get multiplied. So what had been the result over here? 3 would come over here. And as the method of replacement would take place, 3t would be taken as x. So here it becomes sine of x. And towards denominator side already we had 3t, so obviously it would become x. And may I know how the replacement would take place as it has been done earlier? 3t would be taken as x. Once we take differentiation both other side, what would happen? The differential value along with t, differential value along with x. And end of the day, dt can be replaced with dx divided by 3. So here comes dx, and the 3 would come towards denominator side, and as it has been constant, definitely can be brought out. Till this point, each and everything is clear? Obviously, sir, clear. It has been integration from 0 to infinity. 3 and 3, they have been common in nature. Obviously, would not have any weightage over here. It had been 1. And as far as the integration of sine x divided by x from 0 to infinity is being concerned, the result is simply going to be pi by 2. Pi by 2. Agreed, no? So, one of the important conclusion, if you want, we can retrieve out of it. What it is, sir? It has been sine of nx divided by of nx. Either it could have been a form of sine of nt divided by of nt dx, where the limit of x starts from 0 to infinity. May I know what would be the worth of this particular problem? Again, the same process has to be followed. The method of replacement, the n of x would be kept as t itself. Yes. And once we'll take derivative both on the side, it would become n times of dx is equals to of dt. End of the day, dt would be fed as dx would be fed as a dt divided by of n, and as 1 upon n has been a constant value, that would be pushed out. So end of the day, you would be getting the answer as pi divided by 2 times of n. Yes, pi divided by of 2 times of n. Yeah, it's the infinity. Sorry. Mistakenly I have written pi. As we have been following the problems related to the Laplace integration, definitely my limit would remain always fixed. I would start from 0 and would go towards infinity. Manju, that was a mistake which I have committed while forming the problem. In all of the 3 problems or the sub problems which we have represented over here, all of them have got the limit which starts from 0 and goes till infinity. No change. That's fine. Yes, no? So again come back to this problem. May I know how this problem could have been smashed out? So here comes this problem into the phrase page. See what we are going to do. As far as the 2 trigonometric ratios are being concerned, either it is in form of cosine, either it is in form of sine, they have been multiplied together. If their multiplication could have been bifurcated in terms of sine A plus of sine B or sine A minus of sine B, what would happen? Towards numerator side you would be having a sine component, and towards denominator you would be having 4 pi t, which would be common in both of the terms. And end of the day, more or less, this problem has been framed in the same form as we have been taken in earlier 3 to 4 number of problems. Formation of sine of t divided by of t dt, integration goes from 0 to infinity, or sine of nt divided by of nt, integration goes from 0 to infinity dt. just recall the trigonometric identities or the trigonometric important formulas which we have studied in class 11th, and keep in mind this problem have come in gate electronics. So you can't expect this sort of problem would not come in near future. I would say this problem or this sort of problem can be framed in near future. Agreed? So the answer have started coming, sir. Even function. No. Even function. Yeah. Has it been an even function? I wanted to ask from each one of you. Has it been an even function? Has it been an even function? Obviously, sir, it has been an even function. How? Once the t would be replaced with a minus of t. As far as the theta is going to get created within the cosine, obviously there would not be any effect, because cos of minus theta remains cos of theta. And now the t would be replaced with a minus of t, and as the t replaces with a minus of t, the impact of sine of minus theta is being seen as a minus of sine theta. So minus would be taken out, and as the t would be replaced with a minus of t, again the minus sign would be taken out. And as far as this complete structure of the function of t is being concerned, it has been an even function. When the function is said to be even function, when the f of minus of t is very same as f of t. Yes, it has been an even function. It has been an even function. As it has been an even function, rather taking its integration from minus infinity to infinity, rather taking its integration from minus a to a, why don't we start from 0 and go till infinity? Whatever the area would be occupied, the same area with the same magnitude, with the same polarity would be occupied towards the negative value of x. So what we would do, we would take its integration from 0 to infinity, and I would just do the multiplication with 2. Sir, can we take sine 4t is equals to of 2 sine pi t? Obviously you can. No. Who is stopping you? Definitely you can. But definitely still you are not going to extract any of the path through which you can solve that problem. So the methodology you wanted to apply at least on this problem is not going to work. It's not going to work. So at very beginning what you can do, just focus over the cos 2 pi t as well as sin 4 pi t when it takes place. Just try to understand this. If you have the trigonometric identities which we have studied earlier, sin a plus of sin b used to be 2 times of sin a plus b divided by f2 cos a minus b divided by f2, b divided by f2. So obviously this was already there. You can see this would be a larger part and this would be a smaller part. Why it would be a larger part? Because here the addition between a and b had been taken. And why it would be a smaller part? Because here the subtraction has been taken place. So once you will see the actual structure of this problem, the angle within the sinusoidal part has been larger in compare with the cosinusoidal part. So definitely the trigonometric identity which we can apply at least in this problem would be sin a plus of sin b. My dear friend, if the worth of sin would have been lesser than the worth of cos, in that case it would go to the next level. It would go to the next level. But at least as far as the frame of the question has been concerned, it can be easily formatted in this form. Yes, product to sums. We had to convert the product between cosine and sine into form of sums, in a form of its sums. So what had been happening, just try to understand this way. 2 should be present over there. Although 2 is not been presented, but here the 12 has been presented. No, 12 has been presented. So what we can do, we can extract the 2 out of it. So only 6 would be left out. That's the first thing. Or once you will take it integration from 0 to infinity, already the 2 has been brought it out. That 2 can be brought in. And from there I can frame the product into the form of sum. So what had happened over here, integration would be still be taken from 0 to infinity. The 2 which have come out has been consumed with its multiplication. 12 would remain as it is. 4 pi t, no sir, we are not going to touch at all. But here we would be having the sum between sin a as well as sin b. And end of the day, there would be the integration over t. Yes sir, agreeing. I don't find till this point any of the student would have any sort of doubt. So let me focus over the value of a and let me focus over the value of b. Once you are able to calculate the value of a and b, half of the battle is done. Tell me what should be the best answer over this problem. If you want, I can calculate for you guys. A plus B divided by of 2. A plus B divided by of 2 had been 4 pi t, and the 2 would be transferred towards right hand side. It would become 8 pi t. 8 pi t. In the same sequence, A minus B divided by 2 had been 2 pi t. The 2 has been transferred towards right hand side. It would become 4 pi t. 4 pi t. So may I know the two terms, once we add them together, gets divided with 2, you would be getting 8 pi t and so on and so forth. Tell me, what would be its value? What would be its value? What would be its value? It's gonna be 6 and 2. So here comes sine of 6 pi t, and here comes sine of 4 pi t. May I know till this point each and everything is properly digestible or not? So you can expect even this sort of problem may come once in a while, where they are also checking your basic concepts which we have studied as a part of basics of 11th as well as 12th class. 11th as well as 12th class. 11th as well as 12th class. Three is coming, sir. Let me check it out. As per the Ajay Gupta, the answer has been 3. That we had to check it out over here. See, anyways, what we are going to do over here, the 12 has been common. Bring it out. If you want, even 4 pi has been common. So if you want, you can bring that also out. See what had happened over here. 12 divided by 4 pi has been common, so it has been brought out. Here it had been left out with the sine 6 pi t divided by of t. Sine 6 pi t divided by of t, and still the integration has been taken place from 0 to infinity. So what you are going to do over here, t is already been present. T is already been present. So what you are going to do over here, the 6 pi has to get multiplied towards the denominator side, and definitely for just making it compensated, you also had to multiply 6 pi towards the numerator side. 6 pi towards the numerator side. And once you'll come back to the complete calculation where it had been done, sine nx divided by of nx has been equals to of pi divided by of 2n pi. So I would expect all of the students would be able to get this answer perfectly well. All of the students would be able to get this answer perfectly well. So the answer have started coming. According to the Ajay Gupta, the answer had been 3. According to the Pranil Ingle, the answer had been clear, sorry. Nishant Sharma says the answer would be 3 pi. So may I know what would be the best most answer for this given problem? What would be the best most answer for this given problem? I am not going to calculate this question furthermore. I would like to have the input from you guys only. Tell me what would be the best most answer for this given problem. It's not a difficult problem at all from here onwards. No, not at all. It's not a difficult problem at all at any case. No, it's not. It's not. So can I expect you guys would be able to calculate this question by yourself? So I would say all of you should try this problem by yourself. In the same sequence, let me take the question number 6. Let me take the question number 6. Tell me what would be the best most answer for the question number 6. And now we are going to calculate the complete answer for this given problem. Probably within 30 seconds, we would be able to crack this problem out. May I know what would be your first step? Sir, if you wanted to calculate its answer with the help of Laplace integration, the integration should start from 0 to infinity. But here the integration has been started from minus infinity to plus infinity. And as far as the function is being concerned, it has been an even function. That means the amount of area which would be concluded, which would be conceded, which would be covered from minus infinity to infinity would be half if I take from 0 to infinity, or if I take from minus infinity to 0. So rather taking the area under the curve and once through from minus infinity to infinity, I can take the area under the curve from 0 to infinity and I can multiply with 2. Yes, sir, we are doing so. 2 is already been there. 2 is again going to get multiplied with 2. So the factor which would be left out outside is going to be simply 4. And the integration would take place from 0 to infinity. And here it goes sine of 2 pi t. And here it goes pi t dt. Pi t dt. Yes, sir, that has been fine. That has been fine. If you are not able to conclude, sir, if pi do come, we are not much comfortable, so you can follow its traditional method. May I know which traditional method has to be followed? See, you had to bring 2 over here. Once the 2 has been brought towards denominator side, just to compensate 2, the 2 has to get multiplied. So the factor which has been left out had been 8 over here. 8 over here. That is well and good, sir. Now what we are going to do over here? 2 pi t together has been taken as x, and once the 2 pi t has been changed to the x, the limit would not change. Why the limit would not change? Because the x has been 2 pi into t, and once you feed t is equals to 0, the value of x would be 0, and once you feed t is equals to infinity, even the x would be infinity. Or you can say, once you feed 2 pi t is equals to of x, x has been directly proportional to t, so once the t is 0, x would be 0, and similarly once the t is infinity, x would be infinity. X would be infinity. That is fine, sir. That is fine, sir. So here it had been sine of x divided by of x. That is well and good, sir. That is well and good. But while substitution, you have taken 2 pi t is equals to of x. So here it's gonna be 2 pi dt is equals to of dx. So may I know how the replacement of dt in terms of dx would take place? It would simply be dx divided by of 2 pi. If you want, you can write over here itself. Otherwise, 1 upon 2 pi had been a constant value, can be brought out. Can be brought out. Yes, no? So till this point, each and everything must be clear to all of us. So what happens? The 8 would remain as it is. 2 pi had been the component of the denominator, would be brought out, and you have been left out with the same standard form of the integration, and that has been sine x divided by x, which starts from 0, goes till infinity, and that had been equals to of pi by 2, pi by 2. So here the pi and pi goes out, 2 and 2, that becomes 4, 8 divided by 4, that had been 2 over here. That had been 2 over here. Yes, sir? Ajay says, sir, can we also go for area under the sink is 1 and theta a suffix b for scaling? I did not exactly get your answer, but still you can explain what sort of doubt you guys are having. You can put it in the explanatory form. Anyways, the most answer which we have been getting for this problem, has been option D. Obviously, the answer has been 2 over here. The answer had been 2 over here. In the same sequence, let me focus over the question number 7. Tell me what would be its answer. Although we have been dealing with two different kinds of definite form of the improper integral, the worth of sine x divided by of x, where the integration has been taken place from 0 to infinity, is clearly known to me, which has been pi by 2. And if we take the integration of 1 upon 1 plus of x square, or either if I take antiderivative of 1 upon 1 plus of x square, what it used to be? It used to be tan inverse of x. Tan inverse of x, its upper limit would be infinity. In that case, it would become tan inverse of infinity. Tan inverse of infinity is simply equals to pi by 2. Minus of tan inverse of 0, tan inverse of 0 would be simply 0 itself. So end of the day, you have been left out with the pi by 2 once you do the integration of this particular term, and similarly pi by 2 once you take the integration of this particular term. So the answer had been pi over here. And keep in mind this 3 to 4 questions which we have taken now, they have been the problem of previous year gate. Would you like to have few more number of problems based on the Laplace integration? So let me do one thing. Let me design 1 or 2 more number of problems. Let's take the next kind of the problem had been t sine of t dt, where the integration has been t is equals to 0 to infinity. May I know what would be the answer for this? Should I be applying the Laplace transformation for getting its definite value or not? Should I apply the Laplace integration method for getting its definite form of the integral or not? No, you can't. It has been divergent integral in nature. Why? As far as t is being concerned, it has been a straight line. In future, it would become the envelope of sine of t. And as far as the sine of t is being concerned, it has been an oscillating signal. So it would be keep expanding linearly. And as the curve has been keep expanding linearly, and as you have been focusing over the area under the curve from 0 to infinity, definitely you would not be able to succeed to get its precise most answer. Answer would be divergent. So nobody is going to ask this problem. And I know many of the students would apply the Laplace transformation. They would also recall, sir, if the t multiplication takes place in time domain, there would be the differentiation with a minus sign in Laplace domain. I can understand, but that would not be the correct methodology. That would not be the current methodology. Nissan, could you understand what exactly I wanted to say? Because I know many of the students, what they are going to do, first they would focus over the sign of t. They would take its Laplace integration, which would be 1 upon s square plus of 1 upon s square plus of 1, and then they would take its differentiation in Laplace domain and the multiplication with the minus sign. And once the differentiation is been done, what they are going to do, they are going to feed s is equals to of 0, s is equals to 0, which would be utterly wrong. So I can say in future you can get trapped on this sort of problem. You can get trapped on this sort of problem where deliberately they wanted to make you mistake, or they are forcing you to do mistake. They are forcing you to do mistake. Yes, let me move forward. Let me go into the next slide. Deliberately I am making the complete problem a little bit complex. And let's take the problem had been e to the power of minus t times of sin t dt. Now I would like to ask from each one of you, its answer, would it be convergent in nature or would it be a divergent in nature? If the answer would be in convergent in nature, definitely you would be finding a certain finite value of this integral value. If it is so, tell me the exact most answer. Tell me the exact most answer. So the problem has been changed to the integration from 0 to infinity. It has been 0 to infinity. We have been dealing with a Laplace integration. So by default, the kind of the questions which I have been framing now, the limit starts from 0 and lands up to the infinity. And the function has been e to the power of minus t sin t dt. Nishant, just wanted to ask from you, would you be landing to a finite value or would you be landing here to an infinite value? If you have been landing towards infinite value and it has been a form of improper definite integral, the result would be divergent in nature. That's the first thing. And if you have been landing to a finite value, obviously you would be getting its perfect answer. The expression has been e to the power of minus t, which is getting multiplied with t, which is getting multiplied with the sin of t dt. Obviously it would be convergent in nature. How did I know about it? As we take the reference of t is equals to 0, at t is equals to 0, this factor becomes 0, which is going to get multiplied with the complete function. At t is equals to 0, function's worth is going to be 0. At t tends to infinity, this would become 0, and as this becomes 0, again this function would become 0. So as far as this function is being concerned, it has been a well-behaved function. Till t is equals to 0 to infinity, nowhere it is going to make its magnitude as infinity, and obviously it has been a bounded curve throughout the range of positive value of t. So what we are going to do over here, once we'll compare with the standard form of the Laplace transformation, one thing is quite being sure, e to the power of minus t has been in the place of e to the power of minus st. So once we'll compare with the e to the power of minus st, the value of s has been known to be plus 1. So we have been left out with the Laplace of t times of sin t. Once we take its Laplace, purely it would be a function of s, and there s would be fed s plus of 1. Agreed? How the Laplace would be made? You know the sign of t stands for 1 divided by of s square plus of 1. Once we take its Laplace, once the t gets multiplied in time domain, in Laplace domain, there used to be the differentiation. How many times? The number of times the t has been multiplied. And even we also used to have the sign plus minus alternatively. If the power of t had been even, the sign used to be positive. If the power of t had been odd, the sign used to be negative. So end of the day, I can say this worth would be minus 1 to the power of n. Whenever it is even, plus whenever it's odd, it's minus. Agreed, no? So here it's gonna be s is equals to of 1. Agreed? Once we'll take its differentiation, it's gonna be s square plus of 1 to the power of 2. That's fine, sir. S square plus 1 divided by s square plus 1 to the power of 2. Towards the numerator side, what's happening? S square plus of 1 would remain as it is. Obviously, sir, 1 gets differentiated with s, it would become 0. And now it remains 1, and again the differentiation would be taken place for the denominator, which would be 2 of s, which would be 2 of s. And the s has to be fed as 1, s has to be fed as 1, and still minus sign is being presented over here. So what is happening over here? It has been knocked up. Minus and minus would get multiplied together, would become 2 of s. And towards denominator side, we had s square plus of 1, which has been raised to the power of 2, which has been raised to the power of 2. And now we would be feeding s as 1. Once you feed s is equals to 1, obviously towards numerator side, the 2 is going to get multiplied with 1. It would be resulting 2. And towards denominator side, what's happening over here? S square, which has been 1. 1 has been raised to the power of 2, that would again be 1. 1 plus of 1, that is a 2. 2 has been raised to the power of 2, that would be 4. End of the day, the result what we are supposed to get after doing this hell amount of calculation has been half. The Manju wanted to show. Anyways, my phone is off. Manju, I would request at least you have the Desmos application on your Android phone. Most of the time I used to draw the curve over here, but currently my phone is off, so I would not be able to show that graph over the digital board. But definitely once you'll see that graph, that graph would be well behaved graph, that graph would be a bounded graph, and as the graph has been a bounded graph, one thing has been quite sure, what it is, the area which has been bounded by that curve would be finite. Don't have Desmos, but still I would request the student who have been following me since so long, they should have Desmos in their phone. They should, I am saying, they must. I am insisting you. Until and unless you do not have the Desmos, or until and unless you do not have any kind of 2D plotter within your phone, you are not actually attached with the mathematics. Manju, but still I am insisting you. You should have Desmos on your mobile phone. Not only Desmos, there are n number of applications through which you can draw the 2D graph over the 2D plane. Okay, so the integration part is over. This was go to this link. Graph is bounded. Okay, that's fine. Anyways, we have been done with the integration. Although I was wanted to start a new topic, but still when I was searching which are the different kinds of the integration has been left out, I found that this integration is not yet been covered. That is why I have taken this as a separate section. Yesterday's also we talked about the Laplace integration, and in today's class also we discussed about the Laplace integration. Definitely from tomorrow onwards we would start a new topic, and that new topic is going to be secret for all of us. Okay then, bye-bye, take care, good night. The student who have been following me over the live app, they should come precisely at 10:30. There we would deal with probably cylindrical coordinate system in today's class. Bye-bye, take care, good night.